Hello everyone, I'm Cyprian from Midas IT, and we will begin the Midas NFX 2013 release webinar right away. And here I'm with Piotr Stepian.
So hello everyone, my name is Piotr Stepian and today I will perform a new features demonstration for you.
And Apurv Sharma.
A warm hello to everyone. My name is Apurv Sharma and today I will be answering your questions live.
So this is the plan of what we will talk about today. So first of all, I will remind why Midas NFX and what you can do with NFX. And then we will go to the main part, which is the new feature of NFX 2013. Then we'll talk about what is coming next, and we'll show a few product application and next events which are planned. So for the few CAD analysts who are here, I would like to come back to the basic before beginning this webinar, and I would like to say why the engineers need CAE analysis. So all begins with CAD, which represent the model in 3 dimensions on the computer. And so CAD is the design part of the software, and CAE is the engineering part. So after using CAD, the model is exported in CAE software to perform all kind of tests. So it can be drop test, crash test, cooling test, or everything you want. All that is performed in CAE. So why do you need CAE and not just perform the analysis in laboratory, let's say? Because this is very useful when you have a lot of prototypes to test and finally release a final product which is perfect. If you do the test on every prototype, you will spend a lot of money just on the testing. So this is why CAE comes very handy in this kind of situation. Okay, now let's talk about the CAE designer workflow, because in NFX we have 2 kinds of workflow which are very different. The first one is the CAD designer workflow. So when we created Midas NFX, usually we had the idea that the 2 paths can be used. So what I mean is the CAD designers can perform easily analysis in NFX and evaluate the result with minimum operation. Then they can transfer easily the results to another model which has been modified, and finally generate a report automatically in order to submit to their team. So this is the CAD designer workflow, but the CAE analyst workflow is very different. CAE analyst workflow consider very complex models and need a lot of specific functions which are only provided by a very professional software. So how Midas is handling these 2 kinds of interface, I will talk about that a bit after. So the CAE analyst works on very big models with a lot of parts and very detailed models also. So this is why the first thing that they need is a way to simplify all that. So NFX provides a simplification of the CAD model directly in the interface, and it is automatic also. So here it's about the small holes or the fillets. The same about the contacts. When you have 100 parts in your assembly, it's always better to have this automatic contact assignment, because in 2 seconds you can assign everything. If you have to do it manually, it can take, I don't know, a few days to do that. So it's really improving the job a lot to use this auto contact tool. Now Midas NFX is really powerful because it is an all solution in one interface. So what we mean by that is that in the same interface you have all these analysis, so not only linear, model or buckling, but very high-end analysis, nonlinear, static, quasi-static, composite, CFD as well, heat transfer or thermal stress, and a lot more like fatigue analysis, nonlinear buckling, topology optimization. A new one that we've added is the size optimization. We'll talk about that right after. Nonlinear explicit dynamics, nonlinear implicit dynamic, which has been added too, and a few types of CFD. So what is really midas NFX? Midas NFX provides first two modes which are made for the two types of workflow I just described. So one is the designer mode and the other one is the analyst mode. Design mode helps the designer to perform very quickly any type of simple analysis, whereas the analyst mode provides all the features of the high-end softwares, the meshing, manual meshing of any type. It can be 1D, 2D, 3D mesh, any type of analysis, everything. NFX is very efficient to analyze large assemblies very quickly. So here you have a small example of this assembly of 105 parts. So you have automatic contact assignment. So 183 contacts are defined very quickly. Then you can use hybrid meshing, which is also a good part of NFX. And finally, your linear static analysis can be performed very quickly. And what you can see from here is that this analysis has been performed on a 32-bit computer with only 3.2 gig of RAM, so it's a laptop. And so NFX can perform very big models on laptop as well. Another very good point is the fast meshing and the superior mesh quality. So not only tetra mesh or second order tetra, but also hexa mesh, map meshing, and a special type of mesh we have in NFX is the hybrid mesh, which combines the hexa mesh and the tetra mesh. And it links the two with a special pyramid element. So this kind of meshing shortens the analysis time and also improves the analysis results. And NFX is really made for specialists, and all the features you need to, for example, to check the mesh are also provided. So because sometimes you have a model like that and it seems that the mesh is very good if you look externally. But in fact, if you look internally, you see that there's a lot of very bad mesh and the aspect ratio is not good. So especially for CFD simulation, it is very important to have such feature. So I'm just citing this example to show you that midas has a lot of special features which are really required. Okay, now we go to the main part of this webinar and also the most interesting about the new features in NFX 2013. So we'll go first with the new improvements on the large-scale models. All that has been improved a lot in the new NFX 13. So it was already quite efficient to perform big model analysis, but right now the engine has been changed completely in order to tackle the big models more efficiently. So this is one strong point. And now we go at a second improvement about the analysis wizard. So this is something for the CAD users. They require a small help when they are doing the analysis to help them about the process of the analysis. So as you can see in this window on the right, the task pane has been added. So by clicking in this window and following the process, you can perform very fastly a linear static model, buckling, or heat transfer. So for this moment, only these 4 types of analysis are provided for the wizard, but it's sufficient for the new users. So this is the workflow in short. First step is to choose the type of analysis you want to perform. Second step, to import your CAD model. Third step, to define the materials and the properties. So you can import it from the DB of NFX. Load and boundary condition, then running the analysis and the meshing, and finally the results. Now, another feature which is really useful is what we call the cleanup feature, but it's a kind of simplification of the CAD model. So it was already present in NFX 2012, but it was only to remove the holes and the fillets automatically. Now we improved a lot this feature in order to merge the faces and to remove the faces and the edges from the CAD model. So this is very useful when you have very small surface on your CAD model and the meshing is difficult, so you can directly simplify your CAD model inside the interface of NFX. Now let's go to one of the biggest improvements of NFX 2013, which is the mid-surface extraction. So we have three methods to extract the mid-surface. One is the semi-automatic, automatic, and manual. And I will let the hand to Peter to show you how it works directly into Midas NFX.
Okay, thank you, Cyprian. Let me hide the panel. Okay, so let's start from the mid-surface generation. So generally speaking, this tool creates a surface between pairs of selected faces according to your 2D modeling. So it will be widely used if you want to simplify your geometry. So Midas NFX offers following options related to extraction of mid-surfaces. Now let me show you a very simple geometry. So you see sheet metal on your screen, and let me introduce automatic option. So now I'm clicking on the sheet metal geometry and clicking on the apply button. So it's done. So the mid-surface has been generated, and this option is dedicated mostly for solids with constant thickness, like sheet metals. But of course, if you want to use this function for more complicated geometries, you can try to use it. But of course, in everyday practice, you will need more complicated geometries. Excuse me. Now I will open new model. So I will show you geometry of the bracket. Okay. So once again, so as I said, so in everyday practice we can meet more complicated geometries. So that's why semi-automatic option could be better choice. So now let's take a look on this example. So semi-automatic option has been checked, and now I'm selecting external surfaces, and you can see some more preview or created mixed surface. So now I'm selecting the geometry of the rib. Let's select the bottom faces, and let's click on the preview button. So now you have an access to preview your geometry. Now I'm clicking OK. So you see the geometry has been generated. And there is one other thing that I want to add. So after extraction, all of generated faces has got imprinted curves. So if we go to mesh, let's say, and if we want to generate 2D mesh, now I'm changing the size to 3, selecting all of the faces, you will see that compatible mesh will be generated. So there is no need to merge nodes or create, let's say, once again, your mesh. So this option, last option, what I didn't mention today, provides manual extraction, and it enables to create mixed surfaces between suitably selected pairs of solid bodies. So once again, thanks to this comment, you will be able to create, let's say, lighter models more effectively. Lighter means in some cases you will use shell elements instead of solids, and this will lead you to obtain shorter analysis times with the acceptable level of accuracy. And now let's back to the presentation.
Thank you very much, Peter, for this explanation. Let's continue about the new features. So this was the mid-surface extraction, which is very useful when you have a complex model like that, a wing that you want to generate the shell model fastly and easily. So now you can do it. Now, two other improvements which are not so major, but which needs to be told. One is the addition of the creep material models in NFX with three different types of model, two empiric laws and one an input from a table. And another improvement has been done on the radiant heat transfer analysis. So before it was taking a bit some time when you were adding the radiation load. But as you can see here, it has been improved a lot in the new version of NFX. So the time of analysis has been improved to 90%, which is not small. Now let's go to one of the other features that a lot of people were awaiting about this new version, which is the implicit nonlinear dynamic analysis. And this is just awesome. Implicit provide a very great way to perform nonlinear analysis in a dynamic way, and Piotr will show you again in the NFX how it works, because it's really one of the biggest improvement of this new version.
Okay, thank you, Sepia. So let's take a look on the implicit dynamic analysis. So just to remind, 2012 version of NFX was equipped in a nonlinear dynamic analysis feature with an explicit method for obtaining numerical solutions. So now we want to introduce to you second method, implicit, which is also widely used for the same group of problems. So the main difference of these two methods, and I will neglect the theory this time, is the time scale of the solution. So in the explicit method, we are using smaller time steps since it is conditionally stable method. This means that the time step has to be less than a certain critical time step, and this time step depends on the smallest element size and material properties. So also explicit is a non-iterative method. So new method, implicit, is unconditionally stable and iterative method. And this makes implicit more efficient for solving slow speed dynamic. So when the solution time spans a period of time considerably longer than the time of wave propagation through the element, implicit method is usually better choice. So class of the problems are usually almost are covered by most of the structural dynamic problems. And also using this method, no such modifications are needed to provide to your model. So now let's take a look on the example. So the procedure for the model preparation is actually the same as for linear or nonlinear explicit dynamic. So time varying loads should be defined. So now I'm opening the analysis case. I'm going to edit. And setup procedure is very simple. It's very simple and similar to nonlinear static. So as you see, we can create several subcases depending on our needs. So in this case, I'm using a simple impact model, which includes two subcases, drop and impact. So let's enter to the subcase control. So as I told you before, setup is very simple and almost looks the same as for the nonlinear static. All we have to do is specifying the time duration and the number of the time steps. So if you want to consider nonlinearities like material and geometrical, you have to check this option. Okay? let's click twice and let's start calculations. So one of many improvements in the new version of NFX is the interactive graph. You see this on the screen at this moment. So this graph will appear automatically when every kind of nonlinear solution is performed. So I'm talking about the nonlinear static, nonlinear thermal, nonlinear explicit, and this tool will be very helpful to monitoring convergence during the solution phase. So we can follow up, let's say, maximum displacement versus global time, maximum rotation, or even maximum time temperature. So let's wait a few seconds to get the results from the second step case. Okay, I can just stop at this moment. So now I'm going to display the results. Okay. Let's set up the deformation scale to 1, and let's play results for the shell stress output vector. So I would like to add that this model was subjected to gravitational loading, and you see simple impact response. So implicit analysis is also very powerful in many industrial areas. So let me show you two examples. First example depicts metal forming simulation. So now I'm playing the animation. So in this example, a nonlinear material has been used, and due to that we are able to investigate plastic stresses or strains. Second example shows us a structure which is called deflector. So this is an application example from civil engineering, and as you see, all features were used in this model. So we use nonlinear material, surface-to-surface contact has been created. Also, we used all kinds of elements. So we used one-dimensional elements, 2D elements, and of course solid elements. So that's all about this implicit. So let's go back to the presentation once again.
Okay, thank you very much, Piotr. Okay, this was the demo about the implicit nonlinear, and I would like to add something about that, is that now it is possible to see the results during the analysis. So even if the calculation is not over, it is possible to open the analysis case and see the results when you are still performing the analysis. So this is also a great feature that a lot of people required from last year. Now, another type of analysis that have been added and improved a lot is the transient nonlinear heat stress analysis. So it is working in a way that first you have to heat the model, so to apply the transient heat transfer analysis. Then the thermal load is transformed into a load and applied to the structural model in order to see the deformation too. So all that is done in using nonlinear quasi-static analysis, and it makes all that works as transient nonlinear heat stress. And right now Peter will show you again another example of this kind of nonlinear heat stress.
Okay, thank you. So now let's take a look on another type of analysis which has been implemented in new 2013. So nonlinear transient thermal stress analysis combines two types of analysis: nonlinear transient heat transfer and nonlinear quasi-static analysis. So using this type, we are able to investigate stresses or strains, deflections which comes from the temperature loading in the time domain. So on the screen you see a simple example of line heating, and I would like to show you what we need to prepare this kind of analysis. So the main thing is the proper setup for your material card. So to prepare this type of analysis, you need to specify temperature dependent parameters in the material card. So actually you have to provide all kind of functions for your elastic modulus, Poisson's ratio, mass density, and of course for the thermal parameters. Okay, so now let's display the results. As you see on the screen, the output consists of two types of results because we are doing, let's say, indirect method. We are performing this analysis, let's say, indirect method. So we have to create two subcases. One first subcase for the thermal analysis and second for the quasi-static. Now let's display temperature changing. So you see this on the screen at this moment. And now let's display the quasi-static results and let's display total deflection for this simple line fitting model. Okay.
Okay, thank you, Peter. Let's come back to the presentation and talk about the other features that have been added. So now, one thing that we need to precise is that NFX is not only a design software, it is also software to optimize your model. So if you look at all these analyses that can be performed with NFX, so stiffness, resistance, durability, thermal fluid analysis, dynamic noise, or motion analysis, there's something more than that, which is the optimization of all this. So we have two types of optimization right now in NFX which are provided. One is topology optimization and the second one is size optimization. So topology optimization works in that way. First, you have to define a kind of design area for your model. In this, and then apply the load and the boundary condition, and the software tell you what is the best design for the part which is defined as the design area. Then you can make the mesh again and verify if your requirements are met or not. So you can add also some design condition, all that, and Piotr will show you right now in the software an example on a bridge model that have been performed with topology optimization.
Okay, thank you. So, as you remember, midas 2012 introduced topology optimization. So now we have to wait a little bit for the screen. So maybe we can try once again.
Okay,
once again, because
please wait 1 second. We are switching between two computers for presentation.
yeah,
Okay.
Now you see. Okay. So actually, I would like to briefly describe for you what is the topology optimization. So generally speaking, it's the process of removing material from a part while preserving its performance and resulting in lighter designs, which comply with performance and manufacturing requirements. So this is a simple definition for the topology optimization. And on the screen, you see typical example of the utilizing this feature. So as Saker mentioned, this is a design area for the future, let's say, bridge shape. We will perform some topology optimization to find out the optimized shape for our bridge. So this model is subjected to force loading, which is applied in the middle of this block, and the second loading is the gravity. Mesh, as you see, is divided into two sections: design part and, let's say, non-design part. And design constraint for this model was reduction of the volume about 12%. So now let's go to the results and let's display material density. Okay, and let's take to the update model. Let's go to the update model and let's display optimized result. So using this slider, we have an access to display optimized shape. So now I'm gonna to show feature edge only. So you see optimized result for our design area. So using this slider, we can display the density of our elements. Okay, so if you want to save this result mesh, actually you have to specify new mesh size and click export to STL file, because we are using this extension to save our models. Okay, so now Cyprian will provide you a little introduction to the size optimization, which is the second type of optimization, and actually this is the most, let's say, important feature what we implement in 2013.
Yes, thank you, Peter. So as you saw, the topology optimization was a new feature last year, and now we added again a new type of optimization, which is called the size optimization. So it works by optimizing some parameters of your model. So it can be material parameters, but it can also be the thickness, for example, which is assigned to plate elements. So the software will do a kind of sampling of all the possibilities. Then it will tell you which one fit your requirements and give you the choice between different type of solutions. So if you look in this area, this is a first model which has been optimized using topology optimization. Then in a second time, it has been designed using the size optimization. And finally, you get the final model. So I will let the hand again to Piotr, who will show you a demonstration of how this new optimization is working.
Okay. So now we will perform size optimization analysis, and I would like to add one thing. At this moment, we will show you only the procedure which is required to perform this kind of analysis, and we will provide you more details about size optimization, let's say, in next specialized webinars. So today I will show you only the procedure. So let's start. So you see that there's the same bracket as previously. So this model has got constraints in the bottom hole. So now I'm going to display the constraints and loads. So at the bottom you see the constraints, and the force are applied into top holes, onto top holes. Okay. Do you hear us? Huh? Is the problem with sound? Good. It's fine. Okay. Excuse me, Agnes, because I think we thought that we have some problems with the sound, but it seems everything is okay. So let's go back to this example. Okay, so I mentioned about the forces, and now let's take a look on the properties. So this model, actually this is a 2D model which includes two thicknesses. So first thickness is assigned to all surfaces of the bracket except of the rib, and the value is 1 millimeter. The thickness for the rib is 2 millimeters. And now I'm going to analysis case, and we will perform simple linear static analysis. And let's display the global total deformation result. As you see, total deflection is 10.28. And now I'm going to analysis tab, and I'm switching to the modeling mode, because I perform first analysis which will be used for size optimization. Okay, first thing we have to do is to defining the sensors. So I'm going to click on this comment, and as you see, we are able to define a lot of types of sensors. So we can create, for example, nodal displacement sensor, velocity or acceleration sensor, and of course we can create elemental sensors which are related to the stress, strain, mass or volume. In this example, I will use nodal displacement sensor, and let's check this node, and let's display the global coordinate system. So we can leave this X component, and actually our sensor is defined. So let's assume that this will be our condition. So the second thing is specifying the design variables. So now I'm going to create two variables. So in my case, I will use these two thicknesses. So this is a thickness number 1, and let's change the variable length to 50% for the thickness number 2. So this is the second step. And at this moment, I'm going to create design sampling analysis. This kind of analysis is very necessary to provide some experimental sampling data for our future size optimization. So now I'm specifying the name. Okay. So now I'm moving all of sets to design sets, and at this moment I'm creating the reference to our sampling analysis. So now I'm clicking on Add button, and as you see, we created the reference to our linear static analysis with our sensor. Okay. And now I'm going to create some experimental table. So let's say I will use 10 sample points. And I'm pressing the Add Design table. So we created this experiment table. And if we want to display, let's say, the scatter also is possible. So we are able to do that. Okay. Okay, so let's perform the analysis. It will take a few seconds. So as you see on the left panel, we received 10 solutions, which are related to our sampling of, let's say, experiment points. But at this moment, nothing has been optimized. So we can display the results. Let's say, for example, for case number 7. But as I mentioned before, nothing has been optimized. So if we want, let's say, to display correlation results, we can do that. So this graph provides information about which of two variables is more sensitive to change the size, and the influence for the final deflection, let's say, is higher than thickness of the loop. So we can see that. And let's perform the final step, which is the size optimization analysis. So now I'm going to the analysis step once again, and I'm selecting size optimization. Let's specify the name, optimization. Let's assign all of our variables, and let's go to the optimization control. So at this moment, we can select our output request, and we have to provide some constraints function. So now I'm going to press OK. Constraint, excuse me, it was objective function, and at this moment I'm assigning the constraint function. So let's specify the lower bound, let's say 0, and upper bound to 1, and let's click OK. So now I'm going to perform the size optimization analysis, and as the result, we will receive 3 optimized solutions with the reference to the initial design. So we can display total translation for the initial design, and as you remember, the total deflection was 10.28, and we can also investigate the results from our 3 candidates. So optimized candidate number 1 provides us 8.17. Let's investigate the second one and the third one. And now I'm going to the update model because I want to save our optimized model into new file. So you see the table with our results, and from this section, which is generate model section, I'm choosing, let's say, candidate number 1, and I'm clicking OK, and optimized model will be generated. So if we go back to the model, and if we expand the properties, let's say display the values for the rib. So you remember that thickness for the rib was 2 millimeters, and right now thickness of the rib is equals to 1, but the thickness for all of the rib, for the rest, let's say, is increased to 1.1. So actually we can say the model has been optimized.
Okay, thank you very much, Peter. Now let's speak a bit about the we don't have only improvement on the solver or the type of analysis. We have also a lot of improvement on the post-process and the pre-process analysis. And now Piotr will show you a few improvements which has been done on this side.
Okay, so first of all, I will start from the import subcase feature. Actually, this feature is not related with the post-processing, but it could be interesting for, let's say, models which includes big number of subcases. So I will show you what we can do right now. Let's create a linear static analysis. And now I'm going to edit. So let's say we want to assign a lot of loading cases or maybe boundary conditions cases. And as you know, sometimes we need a lot of time to do that. But using this new import subcase feature, we can prepare some kind of template. And we can import all of subcases to our model. So as you see, it has been done. So I just imported three subcases with 3 different type of loading, and of course with the combination. So actually this is the first feature. Now I would like to show you a new feature which is related to the composite post-processing. So let's display the results for the solid form midas, for example. And this feature is called through the thickness plot of ply results. So if we want to display results across the thickness of our composite model, we can do that using this tool. So this is new thing for the composites. Of course, if you want to send this to the text file, is also possible. So you are able to send this data to the text file. And let me show you the last feature which is related to the post-processing. So we add new option for the displaying counter plots. So you see on the screen a simple beam plate model. So, and as you know, it's not possible to display the results for the stress, for the plates, and for the beam simultaneously. So at this moment, we can do that. So now I'm selecting from the shell, let's say shell von Mises at top, and let me choose the bar stress von Mises. And as you see, we are able both results in the same time. Okay.
Okay, thank you very much, Peter. Let's come back to the slides, and I will show you what is coming next. Because something which is very important about NFX is that it's always improving. So we'll always release new version every year. about the new improvement of NFX. And as you see, it's not small improvement. You have a lot of new analysis types and really good features which are entering in the software like that. And okay, so this is what we'll add for NFX 2014. The direct mesh edit and control, the GPU-based high-performance matrix calculation. So by GPU-based, I mean graphic processor unit. So it is actually using the chip of your graphic card to perform the static analysis. And this is very powerful because your graphic card is much more powerful than your CPU. Then we'll add a new type of optimization, which is the bead optimization, and also we'll modify the size optimization by adding more feature in it. So this is for 2014. For 2015, we'll add the GPU-based high-performance dynamic solver. So for explicit dynamic, we'll add optimization on the reliability side and material model for crash and damage models. And for 2016, we'll add shape optimization, noise and sound analysis, rotor dynamics, and high performance dynamic analysis. These are very important features, and as you see, we already have a big plan for all the coming years. Now we'll talk a bit about a few project applications that have been made using NFX. So NFX provides a solution for every kind of industry. So it can be automotive, construction, consumer goods, electronics, equipment or machinery, chemicals or materials, energy, or even medical. And one of the first examples I'd like to show you is the one about automobile industry. So this is a low-speed impact analysis of a rear part of a car. So it has been done using explicit analysis, and only a part of the vehicle has been modeled, and the other parts have been simulated using the concentrated mass element. Every part in this model has a different stress and strain curve, so it is possible in NFX to define like that different material properties and nonlinear materials for each part. You can also combine any type of hyperelastic material with elastoplastic material together. Now this is the results of this analysis. So you can see the crash of the rear part of the car, and it is very important analysis to see the damage that have been done on the car body. So the structure can be reinforced in this kind of case, and this is typically the type of analysis which is used in car industry for all the design of the cars. Now we have a lot of other analysis for car industry, and we will do a webinar which will be concentrated for the car industry later, so you will be informed by mail about this webinar, and I hope you will also join us to hear about all these types of analysis. Now another very impressive case that has been performed is the staker reclaimer. So thank you very much to X Solutions, for partner in South Africa, who generously gave us this model and performed on it buckling and nonlinear buckling analysis very efficiently. So from what he told to me, he meshed all the model in only 3 hours. So it's really show that NFX is quite efficient. So just to give you a view of the model. So this is the model inside NFX. So it has actually 110,000 meshes, and it combined 3D mesh, 2D mesh, and 1D mesh. And this is really a big model. So I will not show it very in detail right now. Okay, another project application, we have this crane stability check. So for machinery equipment for the industry, You can also perform all kind of linear analysis using the contacts, stress, and everything. Heat transfer analysis of TV LCD panels. So this is for clients in Korea which are producing a lot of electronic equipment. This is very important to see the heat stress and the thermal stress which is generated by the heat in this kind of LCD panel, because it's breaking very fast. Now, medical industry. So NFX has also been used for designing some devices for old people. So the stair lift, here you have an example of that. It has been performed very fastly because NFX handle large assembly very easily. And you can see here what the deformation shape and the stress distribution which is used to design the model. NFX is also very efficient in the construction industry for special types of analysis which are combining 3D, 2D, 1D mesh together, like this silo design. Also, few features that have been added to NFX 2013 is the stress linearization, and also we talked about it, the size optimization. So these two features are very useful for this kind of model. Okay, now let's talk about the next event we will do, because it is not over right now. We will organize a lot of specialized webinar for you about different type of analysis and training and everything, and we hope you will join. So I will show you the list right away. But first, the 60 days trial that we will offer to all the participants of this webinar will be provided very soon. So here now the available time date for the trial is the 13th of June, and we will email every webinar participant with the download link about this trial. So 60 days is really a long period, and I hope you will really enjoy these 6 days and perform all types of analysis and tests on NFX. Now, the technical webinar series that we will organize on the end of June and July. So we have a lot of topics: beginner level topics, high-end topics, mid-level topics, and industry applications. And we'll have a small survey at the end of this webinar. So I hope you will help us to fill this small survey. It will only take 2 minutes in order to tell us what kind of webinar you want to see, and we will decide by seeing all the results of this survey in order to fix the dates for these webinars and to see what we can do first. So it's very important to fill this survey. Now you will have on NFX website soon also some case studies and tutorials. So this staker reclaimer model will be downloadable from the website. So we will provide to you the model. You will be able to test it in midas NFX. So you can see how it has been modeled and how efficient is the calculation of the solution with NFX. Now you can follow us also on Twitter and Facebook, and you have the links here. So if you want to see what we are posting every day on that, you can go on this website and follow us here too. We have also a YouTube channel. On it you can find a lot of webinars, tutorials, application demos, user case and more, and also a lot of interviews. So just by going on this link, YouTube user Cyprian R, so you can see all these videos and tutorials about NFX. Okay, now the last part is about the question and about this webinar and midas NFX. So we'll have, let's say, 10 minutes or 15 minutes, depending on all the number of questions. So, and we will answer them in direct. So if you have questions, just write them in the chat section and we will answer to them right now. Okay, first question is about the FEA solver Midas is using. So we are using our own FEA solver, which is based actually on the Nastran code. So it is very similar to what we have in Nastran. And the workflow of Nastran is also, if you are a Nastran user, you will immediately be used to NFX very quickly. Now the question is, can I make the different mesh granulation for different area of the geometry? So this is a question from Florin for Romania. Yes, you can do all kind of meshing using the control of the mesh density, and we have also something called the adaptive meshing. So related for the results. So for linear static analysis, or you can use this feature to tell the solver to remesh at certain areas of the model. We have a question from South Africa here. Can you create groups of meshes, regroup the material properties and the geometries? Yes, you can of course regroup all that into small groups.
Mesh sets.
Yes, into mesh sets. And there's also very, you have another question about if we can display only certain elements of the model. Yes, it is possible, and I will show you again on this staker model. So if you look at the mesh here on the left part, you see there's a lot of mesh sets, and all these mesh sets are defined for a certain type of analysis. Now you have this big model, but it can be cumbersome to work on all that. So what you want to do is only to display a certain part of the screen. So it is possible to do that by activating elements on the model. So you can select an area to display and show only the mesh in this area, and as you see, all the other mesh have been hidden, so you can work properly only on a small part of the design. Now let's see if we have all the questions. I need to collect some points and the information about the values and export these values in Excel. Yes, it is possible to do that. So you can export all that in Excel, including the curves and everything. Have I the possibility to import a file with a lot of points, coordinate of those, and read automatically the values in these points? Yes, this is a type of import that have been added to NFX 2013 too. So we didn't talk about it today, but it is possible now to import a table of coordinates and to create directly the model from this. We have also some question from existing user. Can I use my existing dongle to work with NFX 2013? Sorry. Yes, of course. If you are in the maintenance period, we will provide for free the new update to 2013. So you will have all these improvements as soon as the release is open. Another question from Italy: is it possible to monitor the analysis result during the ongoing analysis? Well, this has been added also to the new NFX. It is now, the problem was before all the results were saved in one file, which was generated when the analysis was over. So this has been modified in order to generate a lot of small files, and now it is possible to open them.
Incremental results.
Yes, so the increment result can be opened at the same time that the analysis is performed. So you can see the result in real time, and this is a really good improvement of this new version 2. Can multilinear material models be created, or is the material model only perfect plastic or bilinear? Good question. Yes, in NFX you have a lot of possibility to assign a nonlinear material. So it is not only elastoplastic model. You can of course assign bilinear models and any type of stress strain curve you have. It is also possible to use hyperelastic models, so comprising rubber models, which and you have also the possibility to input the experimental results into NFX for the rubber models and then generate the model. Another question is, can you create 2D distributed loading on a surface, like pressure profile on a wing? Yes, you can use the function distribution, so you can assign a function to the distribution of pressure. Okay, I think it's almost the end for this webinar. So I would like to thank everyone for watching this webinar. If you have any question, please send them to info@midasuser.com, or you can also send them to me directly. So my email is cyprian@midasit.com, and we will answer the question. We will also send you all the materials from this webinar after the webinar, so the video and also the presentation slides. If you have more questions, please send them by email. Thank you very much again, and please don't forget to fill the small survey at the end. It will be really helpful for us.
Thank you very much.
Thank you, and goodbye, and we hope to see you for the next technical webinar. Goodbye.